Okay, so now let's begin by building our actual monopoly model. We start with some familiar territory. So the average total cost is going to look just like it does under a firm of perfect competition, where there's no monopoly power at all. Right? It's still going to have that U shape. And marginal costs will also be sloping up. Again, sometimes some people put a little like upward, a little downward little curve right here. Some people don't. It's not really necessary as far as the analysis goes. It's going to be the same either way because all of the action is going to be in the upward sloping part of the curve. What makes this different What makes the monopoly different than the perfect competition firm is the demand curve. Recall that in pure competition and perfect competition, no firm can adjust the price. No firm like if a firm produces more, if one company produces more, that doesn't lower the price. If they pull back on production, that doesn't cause the price to increase because there are so many competitors. There's freedom of entry and exit. There's no there's no way to distinguish your product. There's no asymmetric information. So because of those four things, all firms are price takers. Right? The price is just determined by the larger market, and they are just a drop in that ocean. But a monopoly has price setting power. A monopoly has market power. A monopoly has monopoly power. All different ways of saying the same thing. When the monopoly changes how much it produces, it changes the price. And so the way that we represent this is by not making the demand curve perfectly elastic, like we do with a perfectly competitive firm. We make it downward sloping. We introduce some inelasticity. This changes everything. It changes everything because now marginal revenue is no longer the same as demand. They've actually split up. The way this ends up working is that marginal revenue bisects demand. It always has twice the slope as demand. It has the same starting point. But it'll look like this. The mathematical reasoning for this involves calculus. So at the end of this video, I'll do something about calculus. I'll show you the calculus behind it, the math behind it, to show you why marginal revenue always has twice the slope of demand, causing it to bisect. But for right now, just understand that's the difference. Now that we've done that, it seems like it's a small change, and it is a kind of a small change, but it has a big effect. However, the rules for solving the monopoly diagram are exactly the same as for solving the competitive firm. You begin by finding where marginal cost equals marginal revenue. We'll call it Q sub E for equilibrium quantity. That's what the monopolist wants to do. It's useful to draw that line straight up because that is our reference point, just like for the competitive model. We don't necessarily care about any of the points here or any of the points here. We care about this point right here. Then we ask ourselves, at that quantity, what is, that's the profit maximizing point. What's the highest price the company can sell at that quantity and still sell everything? Note, again, this is the same thing we did for the competitive firm. It just didn't really matter because demand was perfectly elastic. So demand was the same thing as marginal revenue, right? Where this intersected was where we were going to put the price at. But now, of course, demand is different. Demand is all the way up here. So this is the equilibrium price that the monopolist decides to sell at. Then we check cost. We ask ourselves, okay, this is the price per unit. What is the cost per unit? It's exactly the same as competitive firm, same order, same steps. We check that quantity at average total cost. We check the quantity at average total cost and we find it's right here. Don't go down here. This point only matters for finding the quantity. You don't reference marginal cost anymore. You don't reference marginal revenue anymore. You only use those two to figure out the optimal quantity. And then you check that quantity against demand and you check that quantity against average total cost. And this finds your profit per unit times the number of quantities, gives us the economic profit. which again we label as pi. Again, it could be a loss. It could be. And in this particular case, it's profit because price is higher than the cost. Note, this is not where we want to be as a society. You always want where marginal cost equals marginal benefit. Not revenue for the individual, but benefit for the whole of society. Where is that optimal amount? Well, it's where demand equals marginal cost. Q star is all the way out here. Equilibrium Q is all the way out here. We thus have a difference between what we would like to see and what we actually see. There is a benefit that is greater than the cost. There's a benefit that's greater than the cost that we do not get to enjoy. And that benefit greater than the cost, that area, that triangle, is deadweight loss. That's the diagram. That's it. We are done. But before we move on, let's do another example. This time I want to show you that just because you're a monopolist does not mean that you are making an economic profit. You could be making an economic loss. You know, your economic profit, I should say, your economic profit doesn't have to be positive, it could be negative. This will also give us some practice on how to do this. So here's another potential monopoly. Costs are here, demand is here, marginal revenue is bisecting demand as normal. So where does marginal revenue equal marginal cost? That's right, here. And so we draw that line straight up. That's our reference point. We no longer care about these two lines. We only care about demand and average total cost. This was just to get us our starting point. That's why it's our first step. We then ask ourselves, what is the most? What is the highest price we can charge and still sell all of this? It's right here. What is the cost per unit? It's all the way up here. Note that the costs are greater than the price. It's negative economic profit, it's a loss. Just because you're a monopolist doesn't mean you are making money, you are just making more money than you otherwise would. Note again, this is the most that they can possibly make. By definition, marginal revenue equals marginal cost is the profit maximizing quantity. That's why they produce there. But just because you are making the most you possibly can does not mean you are making economic profit or positive economic profit. You could be making an economic loss. As usual, we have Q star, where we would like to be versus where we are. And as usual, we have a benefit greater than a cost that we are not realizing, because what people are doing by themselves is less than what we would like to see them doing. Our deadweight loss again. Again, I remind you, this is how monopolies work. They are able to increase prices by pulling back quantity. So they have price setting power, and because they have price setting power, they take advantage of that by reducing quantity to how much they would otherwise do, and that causes prices to rise. So we see this in OPEC, the Organization for Petroleum Exporting Countries. They have the power, they have a disproportionate influence on the market for oil. It's not as much as it used to be, but it is certainly more than any one organization has, certainly any more than one company or country has. And so they have some sort of ability to raise or lower prices based on how much they choose to produce. And they will announce, we're going to produce a whole bunch, and that causes prices to fall. They're going to say, you know what, we're not going to produce that much, and then cause prices to rise. De Beers, as a monopolist, they have a monopoly, well, they used to have a monopoly over diamonds and diamond mines. they would produce fewer diamonds, causing the price to rise. Okay, so now let's switch over to why does marginal revenue bisect demand in the first place? Because it seems kind of weird, but obviously it's really important to recognize that it does, because that completely changes the analysis. Because marginal revenue bisects demand, that means the equilibrium quantity no longer matches the optimal quantity. So we can do this in a couple of different ways. Let's start with a straightforward math way. Now, this way is not something I would ever require people to know for this class, because it requires understanding calculus. If you want to skip past this part because you don't know any calculus, feel free. But if you know calculus, then the logic of the shape of the marginal revenue curve becomes very, very easy to see. And it doesn't take that long. Let's begin by writing a generic demand curve. P minus BQ. Keep in mind this is just a straight line demand curve. We're not going to complicate it by making it nonlinear. The logic will be basically the same. So here we have P. There's an intersect A, just whatever intercept you want it to be, the y-intercept. And then here we have the slope B. Obviously it's negative because demand curve slopes down. And then our variable quantity Q. You know, this, if you know y equals mx plus b, this is very similar, obviously. Except the b is now the slope rather than the intercept. Well, marginal revenue is change in total revenue. So what's the equation for total revenue? Well, total revenue is the same thing as price times quantity. And what you do to one side of the equation, you do to the other. I'm going to multiply this side by Q. I have to multiply. To multiply this side by Q, I have to multiply this side by Q. So that there's a Q tacked onto that A. There's a Q tacked onto that BQ. This becomes AQ. This becomes BQ squared, negative BQ squared. Here's where the calculus comes in, because you can always find the marginal, or the change in total, by taking the derivative. Let's take the derivative of this equation. Well, that's just A, drop the exponent and subtract 1. In other words, here is demand, here is marginal revenue, and the only difference between the two is that the marginal revenue has twice the slope. It will always bisect demand. See? Simple, straightforward, fast, intuitive. But if you know calculus, you have to understand how going from here to here makes sense. If you don't know calculus, there's another way to think about it. There are two areas on this demand curve which make very small amounts of revenue. Remember, revenue is just price times quantity. So this isn't profit because we don't have cost here, we just have revenue. So this has the same area as this, roughly, assuming I drew this correctly. In other words, you can have the same revenue if you have a high price with low quantity as you do if you have a low price, high quantity. The student always gets the same revenue. If you go, price goes down here, revenue increases. If price goes up here, revenue increases. In other words, there's a sweet spot. We have maximum revenue. If we were to graph total revenue, it would look something like this. If you're selling a lot, there's obviously quantity and price are connected really closely, as we discussed, right, with a profit maximizing firm. If they reduce quantity, then the price will increase, and if they increase quantity, the price will reduce. So if you produce a lot, your revenue will be low. If you produce just a little, your revenue will be low. Note that I tried to make this so it covers the whole demand curve, from the intercept all the way to where it hits 0. it hits the x-axis. We'll note how this works, right? Marginal revenue is changing total revenue. So here the revenue is increasing, which means marginal revenue is positive. Here the revenue is decreasing, which means marginal revenue is negative. Marginal revenue is negative. That means it has to be below the line. And if marginal revenue is positive, it has to be above the line. Increasing here, decreasing here. Which has to hit at our revenue maximizing point. This is where we make the most revenue. Again, not necessarily the most profit, because that depends on cost, but the most revenue is going to be halfway. Right? With a marginal revenue is 0. If you produce more, you don't make any more money. And then you keep going and you start losing. The marginal revenue is negative. So that's another way to think about it. It's exactly the same concept, because this is, again, our total revenue equation. It's literally this. So marginal revenue is that. So this is just a graphic formulation of the calculus, but the logic is the same. Okay, so next video we're going to then talk about a few more of the more exotic versions of monopoly and seeing that in diagram form.